This is for geologic timescale, so please try to get to page 181 in your packet. We're going to look at a little bit of what we have to do for notes, some vocabulary introduction. Should also be on page 8 and 9 of your reference tables, so that we can work through some of the new vocabulary that we're going to learn today. So one of the first things I want you to start to recognize that there are going to be 4 major vocabulary words for units of time. Okay? One of those is going to be eons, eras, periods, and epochs. If you've already had the time to read through this and have annotated, then you have some idea of what these particular periods of time mean in terms of total amount of time. All right? Eons being the largest, epochs being the smallest. Over here you have a small geologic period timescale so that you can take a look and see how it's broken down. But on page 8 and 9 of the reference tables, which is where I'd like you to go next, I'd like to point out a few of the aspects of the reference tables that you can be using on a regular basis for anything that's geologic history based. First category, eons. Eons will be our largest category. So the eon we live in is the Phanerozoic. Like I said, it's okay if you butcher the word. I don't care as long as you try to pronounce it, class, if we're still in class. All right, so Phanerozoic. We've got a little time scale over here too. So if you haven't already done so, take a look at this unit here. We've got millions of years ago. So MYA. That's going to be our unit, millions of years ago. It's going to be a little uncomfortable saying these numbers because if you look, you have 500 million years ago. That doesn't sound too crazy. But then down here you have something that says 1,000 million years ago. Don't get confused. Take a deep breath. Let's take a look at this number 1. Now, if we were supposed to make that 1 into 1 million, I asked all of you the other day, how many zeros would you add to the end of that? Fortunately, most of you said 6. So in order to make that 1 a million, we had to add 6 zeros. Now, if we're going to take a look at this number here, it says 1,000. Well, let's do that. Let's put 1,000 here. And then think about, again, how many zeros do we have to add in order to make this million years ago? We had to add 6. Most of you at this point will be able to recognize that that number 1,000 million years ago is really just a billion years if you're to convert it to typical math. Okay? Geology has its way with numeration and units. So this is for specifically geology and referring to periods of time back in Earth's history. So if we continue down the scale, we see 1,000 million years, 2,000 million years, 3,000 million years, 4,000 million years, and 4,600 million years, which seems odd because it doesn't continue with the same interval, but that's because this is when Earth and our solar system formed. That's a nice little piece of information to try to memorize for that Regents exam. Now, the scale is rather large in our 0 to 1,000 million years ago. They do break it down into 10 different smaller gauged interval slices. And that makes it a lot easier to see how much 100 million years is. Now, down here from 1,000 to 2,000 million years, you only have 1 break in the scale. And that 1 break in the scale is going to be halfway. So it's the same as saying 1,500 million years ago, also known as 1.5 times 10 to the 9th. If you don't remember how to do that, that exponent is going to move this decimal over 9 times. Then you're going to get a nice number called 1,500,000,000, also known as 1.5 billion. Okay? Now, these scales are directly associated with all information that is to the left of this dark border line. So everything here that is listed, it may have a bracket, it may line up directly with maybe a dashed line. All of those are directly related to this time scale on the left. I also want to point out within the eons, beyond 542 million years ago, you have something called the Precambrian. Occasionally, the Precambrian can be broken up into Archean and Proterozoic sections. It depends on the philosophy and historical aspect that you subscribe to, geologically speaking. Okay? Within them you have eras for the old eons, being late, middle, and early. Late, middle, and early. We're to zoom up. There we go. Okay. Next we have eras. Eras, we have three main eras within the Phanerozoic. So if you could just kind of imagine, if you were to take this box and expand it up, that's what we're doing on the paper to the right. Okay. So we've got this era that's been exploded for us, larger, to see a more finer detail of geologic time. So first we have the Paleozoic, Mesozoic, Cenozoic. So we've got three eras within the Phanerozoic. Each of these eras are going to be defined by the end of a mass extinction. So the Paleozoic here is going to be the end of the Paleozoic, meaning that is the mass extinction. Right? Mesozoic, the end of the Mesozoic, again, ends with a mass extinction, which I'll erase my borderlines for a moment so that you can see that along that borderline there is information directly related to mass extinctions. Right? This one here being the end of the Permian, this one here being the end of the dinosaurs, and the end of the Cretaceous with the big asteroid. Right? Each era can be broken down into a number of periods of time. Okay? Those periods of time are usually signified by either geologic events or life on this planet based on the fossil record. So within each of these we do have epochs, which are smaller, more broken down portions of time. Once you get past into the Mesozoic, it just becomes late, early, or late, middle, early. Okay? Within the Cenozoic, we have given them more specific names. Okay? And the times are broken down very nicely for us within this time scale down the center. This time scale down the center is directly related to anything to the right of this big borderline. Okay? The only exception is going to be down here. You have a small section that has been broken out past this dark line, and that is the only exception to either aspects of this time scale. Okay? Now, we have to talk a little bit about how to use this time scale in the middle here, and this column, life on Earth, and all columns beyond. Okay? We have to be able to identify maybe how far in the past some of these events occurred, or maybe when some of these life forms existed on Earth. So if we were to take, for example, the Jurassic, I'm going to label this the beginning of the Jurassic, and this the end of the Jurassic. Okay? So the beginning of the Jurassic is 200 million years ago. And the end of the Jurassic is 146 million years ago. So think of it like this. I started this video maybe 10 minutes ago. Oh, I hope it's not been 10 minutes. But let's say it's 10 minutes ago I started this video for this lesson. Writing this down, the word begin, maybe a few seconds ago, is less in the past than the beginning of this video, which is more in the past. So again, the beginning of something is more in the past than maybe something you've just done seconds ago, which is less in the past. So here we've got Jurassic beginning 200 million years ago, more in the past. The end of the Jurassic being 146 million years ago, which is less in the past. Okay? That should be less in the past. All right, so let's take a look at this scale and how we can start breaking it down to analyze what the approximate time frames are for information maybe within life on Earth, maybe our rock record, and when I introduce it to you on the right page, page 9, the fossil record as well as geologic events. Okay, so we've got this example here. We're going to look at the abundant dinosaurs and ammonoids within the Jurassic period. Okay. First things first, where they write these, that is the approximate location on this time scale. So lining up that capital A with the word abundant with this time scale is going to give us our marker on the time scale to start solving its value. So here we've got about halfway. Now if I was looking at earliest birds, I may interpret this location as maybe being a quarter of the way between this gap. So we're going to need to use fractions as well as the amount of total time within this gap for the period to solve each of these pieces of information. Okay? What I'm going to highlight purely to you is going to be the one we did in class, which is the abundant dinosaurs. So let's take a look. We got to figure out total now. So we've got 200 million, and then we've got 146 million. So we got 200 million years ago minus 146 million years ago. We want to find out the total amount of millions of years that are in that gap. So the total, if you do that math, you want to do the math on your own, go ahead and pause the video, is going to be 50, hopefully Carl will behave today, 54 million years total in between for this gap here. Now, we said that abundant dinosaurs is roughly halfway in between, so we can't use this whole 54 million years to solve that value. We're going to have to break it in half, and then we're going to have to do some math with either our beginning or end of the Jurassic period. So here we've got halfway. Half of 54, if you can't do it in your head, throw it into a calculator. You're going to get 27, there we go, 27 million years in that gap. Now we simply have to just remove 27 million years from 200 million years ago, and we will get when the dinosaurs were abundant. Doing that math off to the side, wherever you may have some space, you should get a value of 173 million years ago. And we add the ago back to the unit because we are now talking about how far in the past were there abundant dinosaurs, not just how much time is in between. Let's continue talking about this column here, life on Earth. You'll see that there are a tremendous amount of detail in here regarding life on Earth. You're going to want to read through that, get familiar with it. This is a big chart, page 8 and 9, so it's going to take some time for you to scan through these pages and get used to scanning through these pages so it becomes easier. Let's finish out page 8 by talking about the New York State rock record. So we've got two different icons in the key. We've got sediment, which is going to be this symbol above, where it looks like you've got some dashes and some maybe fuzzy dots inside this symbol. Then we've got bedrock, which is a solid black box. So down here, if we're going to look, let me erase some of this so it doesn't get in the way of your vision. We've got sediments of this time. Now, how do I know what time it is? Well, not looking at the clock, but looking at this, we slide across until we hit the period of time here, Quaternary. So that means in New York State, we have sediments that are of Quaternary age. Come down here, we have some more sediments. These sediments are of Cretaceous age. Erase this in case it's tough for you to see. Okay, so we have Cretaceous age sediments. We have bedrock. Looks like it's on a split between two periods. So we've got bedrock that's in the Jurassic and the Triassic. That same trend continues for all of these other bars for New York State rock record. Now, if there is a gap between these bars, there is no rock record in New York State, okay, for various reasons, maybe due to a lack of the environment being available to create bedrock for New York State, or maybe we have unconformities where there's a large weathering and erosion event that took place over New York State, leading to the loss of a rock record. Okay. Let me just introduce you down at the bottom here because you're probably curious. We will use these once we get to page 9, but these here are all different fossils that you can find within New York State, and they do provide us more identifiable ages for rocks of layers when we are looking in the geologic timescale. Okay? So let's go to page 9. Now, page 9, this is a double page reference tables chart, so you should have both pages open. Now, leaving page 8 open on the left, we're now going to look at how this information ties into the scale on page 8. Okay? That is still to the right of that big dark borderline. So here we have multiple vertical bars, and all of these bars have names. The names that you need to focus on are here in the gap on the bar. Okay, that gap in the bar does not mean that there was a stop or a beginning in time. It's purely to indicate that this bar is associated with this type of animal. So we do have some very strange names. So let me give you a few of them in case you're having some trouble with pronouncing them. We have trilobites, ammonoids, crinoids. Let's pick another weird one. Eurypterids. We have gastropods, brachiopods. Okay. Down here, we got a little section of placoderm fish. Those were vicious, vicious predators of the day. I think you may have remembered me telling you, you talk about 10 to 12 foot animals with big armor-plated heads and like 6-inch teeth. Maybe like 4-inch teeth. Either way, terrifying as it is, okay? So, within these, we can find the beginning and the end of a group of animals. So let's look at dinosaurs because everybody's infatuated with dinosaurs, right? Now, maybe not, but if you are, then you like this. Down here at the bottom of this bar, this vertical bar, if I were to visually or use scrap paper, continue a straight line all the way across. Let's add one to the screen here. So if I were to add a straight line, pardon the board, it's not behaving right now. If I were to add a straight line, not bad, thanks Carl, to this, I'm going to then continue that line. And I know for you it's easier to see this, but for me it's a little bit more challenging. Let me just make sure I've got the right number. Oh, the board's already burping. 6. Okay, so if I were to continue, I would see that dinosaurs may have started showing up. Oh, I miscounted. It's over here. It's a lot easier if you have them both open together. So if I were to continue that line, I would see around somewhere here, I would have dinosaurs. And in this case, we're lucky. We do have earliest dinosaurs actually listed for us, so we could figure out the exact time, how many million years ago. The same works with the end of that. And if you were to try to figure out how long those animals were on this planet, you're simply finding the difference between them. All right, so these letters, all these letters with circles around them, they indicate exactly the fossils you will see at the bottom of the page. And here, these are called index fossils because they give us the ability to index an exact point and reference time for our geologic timescale and our rocks out in nature. So all of these letters are associated with these sometimes very difficult names, which are in Latin. Tip, pro tip. If you see in any Regents question a word like this, or an italicized, very Latin-looking word, you need to get to this page as fast as possible if it may reference anything on page 9 and 8. So if we're trying to determine the age of a fossil, we are going to be looking from directly the center of this circle and all the way across to the time scale. Over here on page 8, that will give us what period of time and even if we need to solve the actual age of that fossil. Okay? Now because of that, that means if you find this fossil R, which is Bothrolepis, which is one of our placoderm fish, you will see that this animal only exists right here. Therefore, any rock that has Bothrolepis is, if falling across, is in the Devonian. Right? Let's continue our reading here. So important geologic events, I ask you to please read through these as much as you possibly can and get familiar with what's there so that it will jog your memory when reading a Regents question. Okay? Now, you'll see these words orogeny along with words like Alleghanian, Acadian, Tucanian. These are all mountain building events back in history for the state of New York. Over here you'll see that we have individual models that they've provided of what we expect what we expected the plates to be based on continental movement and drift. Notice that North America is this dark symbol here, and the equator runs down the center, something you don't ever want to forget. Okay? So the equator is here. So it looks like for several periods, if not for several hundreds of millions of years, North America was near the equator. As it continued to drift further and further north until now we call it North America because it's north of the equator. Okay? This is as close as we can get to an image that we need for present day Earth. This is 59 million years ago. Please don't get that confused with where we have our continents now in present day. The arrow, there's a light gray triangle that points to the scale so that if you needed to, you can follow along and find its time period. Let's move on and start to try practicing some of the questions that are associated with these problems. So right now we're at a place where you should pause the video, start working through some of these guided practice questions. I would like you to try to do question 1 and 2. I will leave questions 3, 4, 5, up to number 13 will be on your own for independent practice. I do have the access points. I do have the answer keys located in the parental student portal, which is on Google that I share with all of you on Google Classroom and through Jupyter. Okay? So now's a good time to pause. Okay, so you had a moment to be able to attempt these questions. Maybe you need the access point. No shame. Sometimes we need a little help with the first step. And hopefully you've spent some of that time while you paused looking through the Earth Science reference tables and trying to determine where everything is and kind of getting a good feel for it before diving into these questions. Okay. So this first question which says, which life form, by the way, we are on the Geologic History Guided and Independent Practice document, okay, because they are separated by that in my folder. Which life form existed on Earth for the shortest period of time? Well, everything on page 8 and 9 deals with time, so let's try to figure out how to determine the shortest period of time. I don't know where to go. We have all this information here. We have all this information here. Okay, I'm not really sure where I need to go. So let's take a look at this question. I have some possible solutions. I have dinosaurs, trilobites, ammonoids, placoderm fish. Those 4 are in some of a non-specific stating way. So like it's just the basic animal for each of these. So what I'd like you to do is to think, okay, what place on the reference tables will I find all of these kind of packaged nice together? So there are 2 places you could start to investigate. You could start to investigate here, but then if you're looking for the animals here, you've got to do a lot of calculations. And that's not terribly efficient, okay? So let's try to see if there's a different place that might have those 4 animals. All right, we have them here. So we have dinosaurs, we've got ammonoids, we've got placoderm fish, and let's remember what the last one was. Oh yeah, trilobites. All right, so trilobites are over here, ammonoids, dinosaurs, placoderm fish. This is showing you how long those animals were living in time here on the fossil record. So we just need to figure out which one has the shortest stick or the shortest bar. Turns out to be placoderm fish if you were to look through all of them. All right, so we would have choice 4. Okay? So oxygen in Earth's early atmosphere was first produced during the Precambrian from, all right, keywords, oxygen, atmosphere, Precambrian. First, we got to start scavenger hunting the reference tables. So if you are looking for something maybe in terms of this weird word for the time period, maybe we're going to start looking for that vocabulary. So I'm looking here, I'm looking here, I'm looking here. I don't see anything about Precambrian yet, not yet, not yet. I don't have anything over here, or here, or here. Right here, Precambrian. Okay? So we are on the left side of the big dark line, the big dark borderline. And we have to find out where there might be information about oxygen. Looks like I have information about oxygen here. I'm going to read through that. Okay, oceanic oxygen begins to enter the atmosphere. Okay, that might be helpful. Oceanic oxygen produced by cyanobacteria combines with iron, forming iron oxide layers on ocean floor. Anything else about oxygen? I don't see anything else about oxygen. Well, that's kind of handy. It looks like our first choice here talked about cyanobacteria in Earth's oceans causing it to be first produced in the Precambrian. Yeah, I like that. I think that's definitely your answer. Okay? So now is the time for you to continue your independent practice And if you need to, feel free to rewind and check out this lesson again if you're struggling. And if you are struggling, send a message down below the video and I'll try to return a comment as soon as possible. Thanks for watching.